Cordial greetings to those who are part of the National Commission on Development of Aerospace in Peru. A cordial hug to the head of the institution, Major General Martin Tuesta Marquez. It is an honor for the Bolivian Space Agency to address you and to contribute to our approach as brother countries. Special recognition also to the Ministry of Foreign Affairs of Peru and to the whole Peruvian government for this approach between institutions devoted to the research of the space. From the Bolivian Space Agency, my name Peter Mauricio Larrea, Executive Director of the Space Agency in Bolivia, and also from the Ministry of Works, Ivan Arias, and the President, Janine Áñez. It is our fondness and the confirmation of this brotherhood to be present with you through this small course that will be given by one of our best engineers of the Bolivia Space Agency, Engineer Alexis Andrade, who is a member of this agency for many years, who has accumulated a lot of knowledge on space issues. With all of our tenderness and friendship, I will invite you to this presentation by Engineer Andrade, and my acknowledgments in these difficult times from the Space Agency, from the Bolivian government. So cordial greetings. I hope this presentation will be useful and that you will like it. Thank you, gentlemen from the National Commission of Research and Aerospace Development from the Space Agency of Peru. Thank you for your invitation. My name is Alexandra. I am the Director of Engineering and Development for the Aerospace Agency of Bolivia. It is a pleasure to share with you through this video. We thank you for the invitation, for your consideration from General Martin Tuesta for allowing us for this invitation, and also through this to have the opportunity to share and tell you about the Bolivian Space Agency. I will start my presentation with a summary of what we're going to hear in these next minutes. First, about the Space Bolivian Agency, and then we will go to the main characteristics of the TKSAT-1. We will talk about the control Earth stations that we have in Bolivia for the control of the satellite. We will talk about the launching vehicle that has launched our satellite to space and the main applications of satellite, and then briefly some of the social impacts of this launching of the satellite. The Bolivian Space Agency, it's a public national company, a strategic company of the plurinational state of Bolivia, created in February of the year 2010, so more than 10 years ago. So it is under the Ministry of Services, Public Works and Housing, and the first mission, it has been to manage and implement the satellite program TKSAT-1, and it is in charge of future works, space works of the country. The mission of ABE is to manage and execute the implementation of the state space projects, as well as to simulate, develop, and apply the space knowledge for the benefit of all of the Bolivians. The vision that ABE has is to be a world-class company that may provide services with excellence and innovation, that may participate actively in the exchange of knowledge with the international space community, so that the benefits of this technology, space technology, may reach all of Bolivians. The strategic purpose is to manage, implement, and manage the space projects of the state, and thus promoting the technological transfer. And concerning the policy of quality managed at ABE, the ABE should work together with its clients, work with them on their side to provide services and products that are proper to their needs and their requirements. The objective of ABE is the quality, is to reach the highest level of quality, to make their clients loyal to our services, Yes, in these agreements with ABE. So we comply with laws and regulations that regulate our services. We work with the quality management system where we search that the main beneficiary should be our clients, our customers, users. So we have human resources capable and committed with our mission, with our objective, with our quality policy. The ABE was created, started as a project to close the digital gap, existing digital gap. There is a great difference in general in our Latin American countries between the services available in the urban area and the services available in the rural area. So the satellite is the best technological ally that a country may have to close this gap. It's the best tool available so as to approach to reach the telecommunications or to bring telecommunications to remote, to inaccessible areas, to remote areas that, however, we have part of our scattered population. So this is the objective of the launching of the satellite and why the state has a satellite. In this chart here, you may observe how the rural area had for the until the last 50 to 70 years 70% of its population, and the urban area was 30%. But in the passing of the years, that has inverted, so 70% of the population are in the urban areas. Most part of this population have access to all of the telecommunication services, mostly, but in the remote areas that's difficult, and 30% who are in the rural areas, and most of them, of this population, they have difficulties for the access. So this is the objective of the satellite, to cover that. Bolivia is comprised by 3 geographical areas. This is a characteristic of our mountains, the plateau, the subandean areas in the valleys, and the plains. We have a scattered population and in some very remote areas. This is a characteristic that makes it very important to have our own telecommunications satellites with technology, proper technology to reach these distant areas in our territory. As we were saying, ABE was created on February 10th, 2010. 3 years later, 4 years later, on December 20th, 2013, our satellite was launched from Xieshan station in China. It was launched, and a year later, we had geostationary satellite tests were performed in orbits. Satellites, the parameters have been identified to start on April 1st, 2014. It started the commercial operations. Some of the characteristics of the satellite, it is that this is a satellite of communications. It works on a platform DFH4 from the company developed by CAST, and it is in the position 87.2 degrees west. It has a window where it has from 0.05 degrees from the Earth. So the cube, that's where the cube is in the satellite, providing coverage to all of the national territory, but also regionally. It has 5 antennas and 30 transponders. It works with 3 bands, the C, KU, BSS, and KA. It was launched in December 2013. So from that date, it has 15 years more to provide services. The launching vehicle was the Long March 3B enhanced that took it into space. Basically, the satellite has 2 big systems, which is the system of the platform and the payload. As any other satellite, within the platform we have several subsystems: the telecommand, telemetry, telecommand, and tracking, which allow us to know the status of all of the subsystems and components, and to be able to send commands to it so as to keep it within this cube in its orbital position, and also to track and in this way to discover the orbit, which is describing around the globe. So these data is where the commands are sent, calculated from the Earth, to keep the satellite in its orbit. It has a subsystem of a manager on board for the sensors of the commands. It has a subsystem of electric power in order to generate the power necessary to provide the communications. It is comprised by panels. For this task, it has a subsystem of control of position and orbit, and it works the whole time in an automated way. It is not controlled from the Earth, so the satellite controls it automatically, and it is aiming for the Earth, so as to toward the communications beams to the Earth. It also has a unified propulsion subsystem, so this may be corrected in the cube. It is like an actuator in this process of positioning or repositioning. Yes, the changing of its positioning. There is also a thermal control subsystem, because at 36,000 kilometers from the Earth, it suffers from extreme temperatures. So there is a subsystem which is basically passive. It doesn't have any active elements that allows keeping the temperature in the range of operations. And finally, the structure subsystem that provides the physical support to all of the subsystems. Concerning the payload, as we have mentioned, the satellite has 5 antennas. One antenna is in charge of the receiving commands, Earth commands, and to send the data from the satellite, and also to send the data for its tracking. The other 4 antennas work in each one of the bands: band C, band KSS, band K. They are very distant. If we start from 3 gigahertz and they reach 20 gigahertz, something we'll see later. This is precisely the KUFSS band that covers from Venezuela towards Colombia, Ecuador, Peru, and of course Bolivia, Paraguay, and Uruguay. And its range of frequency, it's between 11 and 12 gigahertz, and a reception and uploading of 13,000 to 14,000. It works with a linear loading polarization. And next we have the C band that covers the whole of the South American continent. So we have 3 transponders of 22 by 28 megahertz, and the frequency of transmission is around from 3.6 gigahertz, and the reception 6 gigahertz approximately. So when we were observing the first band, the KAFSS, we have 22 transponders from the 30 that the satellite has, and in the C2, so KFCC includes more transponders, since it is the more commercial band for geostationary satellites. In KUBSS we have 4 transponders, and then we can add we had 22 K plus KUBSS, 24 plus 4 in the KUBSS, so we will have 28 transponders so far. Those 8 transponders, they are designed to, initially they were designed for the dissemination of TV signals and radio with a circular transmission. It only oversees the Bolivian territory, but because of the power, the side beams also reach to the south of Peru, the north of Chile, and even part of Paraguay. The KA band, it is a band that is being used by the satellites, the cutting edge satellites, since we have a higher spectrum in this band. So you may issue more rates only for Bolivia. There is no need to have more power in this band. So here we have two transponders, each of 120 megahertz. Well, about the launching vehicle, this is a vehicle of three phases or stages. It is traditional non-reusable. It uses liquid fuel, also developed by the Chinese Academy, CALT, with technology of launch vehicles. And as I was mentioning, it was launched from Xishan on December 20th, 2013. So midday for China. Uh, so the launching vehicles are three. Now they have a fourth station, and ours was launched from the three that it had in China. The one more located to the south, since the satellite, since it's geostationary, the best zone to be launched was around the equatorial line. So that's why that was the reason. And so this, as I was saying, this vehicle consists of three phases or stages, and the reusing of this. Yes. Once the satellite has been launched, has left into the space, and has reached a height of 200 kilometers from Earth. However, it should travel by itself without any other launching vehicle. It should act as itself until the position of 87.2 degrees. At that distance, not only 200 kilometers, but 36,000 kilometers from Earth. This is a satellite very distant from the Earth, but at that distance, it has the property to spin around as the Earth spins around its own axis. So this is where it, yes, supports the Earth and providing light to a specific point. So here we observe that goes to an altitude of 200 kilometers and then 500 kilometers. There are some maneuvers. 5 maneuvers are performed for the positioning to take the satellite to the position where it will start working definitely. So since that day, there is maintenance performed to leave it in the same position. And precisely for this stage of maintenance of the position, to leave it in this cube, imaginary cube, let's say, where the satellite works. For this criteria, we have two Earth stations. One Earth station of control is close to the city of La Paz, and the other one near the city of Santa Cruz. The main station is in La Paz. So basically, these stations have the same capacity for the control, the monitoring, and the tracking of the satellite. Both stations may cover the same functions, and that's how they do it. Some maneuvers are done from La Paz, others from Santa Cruz. We have staff at both stations. However, also the Earth station in La Paz has the communications antennas that allow us to provide services to the end users. Concerning the control Earth stations, they are basically four main tasks: the follow-up, tracking, the reception of telemetry data to analyze their subsystems and components, and to send telecommands. And these telecommands may be to maintain the orbital position of the satellite, or also to perform some changes in the settings of the satellite, things that we haven't done yet. So once the satellite has been launched, it's still with its initial setup, since it hasn't been necessary to add anything for proper use. Now let's talk about the applications of the satellite. So the first application where we will start commenting a bit is the television, or DTH. In this application, through the satellite, there are TV and radio images captured in urban and rural areas as well. In the whole country, we have two heads of TV. One is from ABE, our own, and another area is from our main customer, which is Entel, the telecommunications company. Entel provides a service through a paid service with premium channels, a sports channel, international channels, and so on. So, but also ABE through its head, because it's in Machuma, it emits signals of TV and radio in a clear and yes open way. So it's that anyone is in the Bolivian territory, but also as I was mentioning, in the neighboring communities, they may capture these signals. So for this model, our clients are the emissions from TV and radio who want to use this service for transport or to expand its coverage. So it has been achieved that most of the national channels will be our customers and will transmit using these satellites. So from many places in the territory and many communities, for the first time, they have received a TV with only one antenna that you may find at any market of electrodomestics, very easy to install, and then around 50 signals of TV and radio, all of them national. So basically, the application of TV. And from the other part, we have the SAT systems. We have two systems, cutting edge technologies from the biggest companies in the world. So you probably remember the VSAT system. Through VSAT, we have satellite internet in two modalities. One is internet satellite productive, internet satellite for small, medium, and big entrepreneurial work. And we have, for the first time in the country, it is provided, a company provides the service of satellite internet to the homes. So basically, it is directed to those countries that do not have an opportunity or access to other members, so as to have this type of so in this case you can do it through the satellite, the Tupac Katari. Concerning the impacts, social impacts, we're going to see some of them. And the company, the National Company of Telecommunications, has implemented in the whole national territory hundreds of telecenters. This implementation and the cost of the implementation of this system, VSAT from one side, but also from the telecenters themselves, that they had to equip the telecenters with computers. So this was funded by the social inclusion company for the nations. Many of these centers work is an access for the community. So it involves the mayor, the municipalities, the colleges. So this is an impact through which many of our connationals have had access to internet. And on the other hand, we have the television, TV. Our users or consumers don't have to make any monthly payment. They can only get a kit, a reception kit, like anybody else in my company. So it has about 50 signals. So this is an important way to integrate many Bolivians who were not integrated before, and in many cases, for the Bolivians who were at the borders, they could capture more channels, foreign channels, than the rest of Bolivians. So now, at any point of that territory, they can do it. The main purpose is to continue growing. It is estimated around 400,000 homes in Bolivia already have an antenna free of charge, free of monthly charge, but also with quality. The same way, there have been projects of health and teleeducation that in this context of the sanitary pandemic, health pandemic, all of our countries have to reactivate. In the case of telehealth, the the past management installed around 200 visa terminals so that they can have their own health centers, so their physicians may have access to a center of the health ministry to provide this, yes, from the city capitals to provide this assistance. And on the other hand, the Ministry of Education for several years has implemented a TV channel through which they were training on technical issues on computers to the population. That's also something that we expect these scopes to be started again. Another aspect of the use of the satellite is to to provide some governmental services. For instance, to issue the ID and the institution that issues what you call DNI in your country, the ID, the personal ID. So there is these are mobilities. It requires, yes, or it checks on the mobility of the person. So, and that will aim an antenna and a satellite, so they can be observed up to our Earth station. So it is this small station satellite, and our Earth station is also connected through fiber optic with servers and database. And thanks to this interaction, they can channel this. This happens in a similar way with the control of highways, specifically the control of highways of the institution of the national customs dedicated to all of the borders. We use the satellite to comply with their purpose. So next, we show you some of the clients we have. We already have clients for all of the branches. So any of the applications a satellite may have, our satellite already has it. Currently, it's being used at a capacity of 60%. So we have an interest of satellite use that we provide for home and service as well. But we also have others who, through the satellite, they provide internet satellite service. We provide data service, so other institutions may connect through us. And within them, besides those mentioned, we have the oil sites company that they transmit the signals for the control and monitoring of their transport plants or production. They go, or distribution, so they go through the satellite to their station, Earth station. In this case, they have their own hub, and they connect to the subsystems. So we also have these applications. And another important application that the satellite has is that it is used by our customers. It is the backhaul mode from two of the three mobile operators that the country has. With yes, they connect to the ABE satellite for the distribution or provision of their mobile services. Most of them are connected to the satellites. 650 bases are scattered, but it is possible to expand. So the Bolivians may have access to 2G, 3G, and 4G. The three technologies go through our satellites. So these are all the applications we have. ABE is still in a process. It's a young, small company. We have an amount of workers, for 90 people working here. So besides, we are changing our focus for some time already, not only to provide capacities from the satellite, but also to provide services to other areas. So this way to reach more Bolivians, so that more Bolivians may take advantage of the satellite. Additionally, we have new challenges. We also hope to continue working with Peru. Our system of dissemination of the TV and radio signals, yes, that has coverage in the whole of the territory, Peruvian territory. So it would be very convenient to be able to use this platform. So, for instance, to transmit channels of TV and radio, Peruvian, for us, that would be a pleasure, and we are ready. We have the technology, we can do it. And all of this concerning the Tupacatari satellite, but also as a space agency for the last 2 to 3 years, basically 3 years, we set up, we implemented a laboratory of processing and analysis of satellite images that obviously doesn't work with our satellite because this laboratory works with other satellites that provide satellite images. The laboratory has already subscribed several agreements with institutions, governmental institutions. The purpose of the laboratory is to be able to generate products, indicators for the decision makers. The purpose is to increase the demand of the use of these geospatial tools. So every time or more and more, they maybe use these tools available, and that nowadays they are a fundamental tool for the proper decision making to organize planning. Yes, accurate or the right planning. So this is the work that the lab has. The agreement subscribed has been that some national institutions, in other cases with other funders or other institutions, and they trust our work. So this keeps on growing. We also hope that ABE may achieve this objective to increase the use of this tool for the national planning. So this is a scenario of the Bolivian Space Agency, of its services, uses, and scope. We thank you once again for the possibility to share this virtual space, to be together this way. Our predisposition to keep on working with CONIDA, it is intact. We have been doing it already for several years. We have had meetings in Peru and Bolivia, and we would like to continue in the near future. Thank you so much for your attention and for the invitation.